Hello everyone, my name is Cosmas Ifeanyi Nwakanma and my co-author is Goodness Oluchi Anyanwu. We are presenting a paper titled IoT Device Temperature Forecasting in this international conference on IoT-based control networks and intelligence system, ICICNIS 2020. It is my pleasure to present this paper to you all. We are going to follow this outline, introduction. We are going to show our purpose for writing this paper and what we have contributed. The proposed work, how we treated our data and what was used in treating the data, the description of the kind of data set we got and where we got them from, our results, and we concluded while remembering us that IoT is a big news because of all that it has presented in the recent time, and so it is important that we are talking about the possibility of reaching out and touching everything. What is IoT? Internet of Things. Internet of Things. Fridge. Internet of fridge. Internet of vehicle. Internet of computers. Internet of microwave. Internet of CCTV. Vehicle to vehicle. Computer to computer. Computer to wearables. Wearables to computer. Your light. Smart homes. Smart cities. These are things that makes people's life to be smarter and to be better. The idea of making everyday objects a little more interactive is what we refer to as Internet of Things. For example, somebody wearing a heart monitor implant, AI-powered refrigerator giving you alerts when there's a food shortage, biometric scanner, or an athlete wearing wearable devices to monitor the extent or progress of the gym and exercises. And as long as there is a natural or man-made object that can be assigned an IP address, then we are talking about Internet of Things. Over the years, we have seen the growth and the continuous growth of enormous data from IoT devices from 2013 when we had 0.1 zettabyte to 2020 where we have over 4.4. So the possibility of continuous growth in data accumulated by IoT devices cannot be overemphasized. But what is important is, what do we do with the so much growth of data in the IoT devices? So in this paper, we're looking at the possibility of IoT that is everywhere, gathering data. How do we optimize the performance? How do we make meaning out of the data that has been collected? How do we make useful inferences for everyday usage? For example, in this paper, we have been able to try to make meaning out of indoor and outdoor temperature environment of a room or of a house, so that we can forecast, for example, a building energy consumption or forecast an energy consumption of a city or whatever. So in this paper, we address the challenges of machine learning used in analysis of data. Also, we look at the possibility of processing the data using Jupyter Notebook. We also did what is called data wrangling, perform on messy data columns for the easy access and analysis of data. For the purpose of visualization, we made use of EDA, and for the purpose of time series forecasting of our data, we made use of what is called Prophet in Python because it works best with time series data, and also especially when that data has trends and seasonal structure. So in this work, where, like I've said in the last slide, we presented our data in an acceptable format because the original data set was not too easily formatted. So we made use of EDA for the modeling, and we made use of visualization techniques. Then we make sure that the data is presented in a manner that it can be well understood. So the data set that was used contains temperature readings from IoT devices that was installed in the room and outside a room. And for the purpose of anonymity, we have kept the identity of such data from this paper. So what was our purpose for gathering data in the room and outside, and what is the purpose of our using machine learning to analyze or to predict or to forecast? The essence was to know the relationship between the inside and the outside temperature of these devices. The next purpose was to carry out a trend analysis, and then with the trend analysis, understand the temperature distribution, and with the understanding of temperature distribution, being able to predict future temperature using time series modeling, with the assumption that the temperature pattern and distribution follows time series pattern. And to be able to do that, we went for a data set. As you can see from our PPT, the source of our data set is www.kawgle.com. There you have data sets of the indoor and outdoor environment, which was recorded randomly at a speed per seconds. So for more understanding of this data set, you can visit this website, or you can also give us a private chat. So after the analysis, after the preparation and everything, this is the result. In this result, you can see that the outside temperature has a larger time series change when compared to the inside temperature. Probably we are going to explain the reason, but this is the analysis of the data set as collected. For the issue of this place distribution, also again, outside temperature has multiple distribution, inside temperature has single distribution. Like I said before, we are going to explain this in the next slide. In this one also, we carry out what is called the variance of temperature. Variance of temperature has to do with the spread of change. To what extent were the temperatures changing over time? And you could see again that the outside temperature had more changes compared to the inside temperature that has a smaller variance. Now, what can be the purpose, the reason behind this? The reason is that the outside temperature, the IoT devices were only capturing temperature values. They don't have control over the temperature. And of course, outside the room, the temperature control were more of nature, while temperature control within the room were also not necessarily nature control, because in the room there are also what is called temperature building materials affecting temperature, the type of material that was used to design the room, the type of devices that were in the room, the facilities that are also provided in the room to control the temperature, like the cooling or the heating devices and the rest of them. So this is very useful research for people who are into HVAC, those who are into studying of temperature behavior, temperature control and monitoring and control of buildings and also of the environment. So with the understanding of the pattern and behavior of the temperature, we decided to do a prediction of 13S points. So in our prediction of our 13S point, we were able to predict the possible values of temperature both for the in and for the out of the building. And of course, you can see from our table that our prediction was successful, even though the accuracy also can be improved by fine-tuning the machine learning algorithm. So in conclusion, in this paper, we try to show the clear differences between the distribution of temperature inside the building and outside the building. We try to show the models that were developed, even though the results were not, the accuracy can still be improved upon, but the result was also good enough to explain our intention and our purpose. But we also encourage more research in this area for the need of optimization of our algorithm for better prediction. Also, apart from the machine learning problem, we also discovered that the possibility of another problem is also the missing data in the data set, and that can also affect your machine learning algorithm and also can make you have a poor accuracy result, even though your machine learning is perfect, but the data set is not also well captured over time. It also can affect your result and can be missing data sets. So to solve the problem of missing data, we suggested interpolation, but with a caution, because interpolation also comes with its own challenges. Sometimes interpolation also makes your machine learning result not to be so accurate, because you tend to replace the missing data with a specific type and number of data, which is also not reliable and trustworthy. So in future work, we are considering the possibility of developing models that can accommodate data sets that are messy, data sets that are having so many missing points, and being able to have a better accuracy and also finding relationship with different features in our future work. We hope that this has been able to contribute to knowledge, and we also hope that people who are also interested in IoT and machine learning related area can collaborate with us for future works. We want to end by reminding everybody who thinks that the internet has changed their life to think again, because IoT is about to change it more. And so there is need for continuous research work in IoT and IoT related areas. Thank you. Thank you very much.